Hi everyone, my name is Joseph and this is my submission for SIT708 PassTask 4.1p, a personal event planner Android app built in Java using Room, Jetpack, navigation and material free. Let me show you the app first, then walk through the code. As you can see on the screen, we have the dashboard where all upcoming events can be seen automatically sorted by date. We have different categories as well. Tapping on the new event button would load the new event fragment, add event fragment where you can add a title, location, category, and all of that stuff. Suppose if I save a event without adding without saving a title, then you can see there is an inline validation error. Let me add a real one. Test event video. Social location deacon. If suppose, as you can see, when I select the pick date option, we can see the past dates are grayed out. That's the logic validation from subtask 4. If I select a future, suppose if I select a date and then if I select a time, 5 p.m. Okay. Now, when I click on save, you will see a snack bar which says the event saved, and we have shifted back to the event list. And you can see a event here where, and if since as you can see, we have different four categories of work, travel, social, and then we have one more other. Yeah. So now, if I want to edit a particular event, if I click on that particular event, it will open the edit event fragment. And here you can basically change a lot of things, all the fields that have been provided. I'll just update the time. And if I click on save, the events get updated over here real time and you will see the real changes. If I click on that and if I want to delete the event, if I click on delete and there the event goes. And since we have to prove room persistence, I'll remove the app from the background and then start the app again. And as you can see, when I open the app, all the events are still there. That's subtask 2, which is local persistence, which is basically room database. And now going through the UI, we'll talk about, since this is basically a single activity file and the subtasks required fragments over multiple activities. This activity holds a nav host fragment and a bottom navigation view, uh, as you can see on the XML file. The bottom nav is wired to the nav graph in 3 lines inside the main activity. I'll show you that main activity file. As you can see, the bottom nav is being attached to the nav graph with the setup with nav controller. Setup with nav controller, it's attached to the nav graph that we have set up over there. I'll open the nav graph now and we'll see all the fragments. So we have 3 fragments: event list fragments, add event fragments, and edit event fragment. Uh, um, Bottom nav switches between event list fragment and add event fragment. The edit event fragment only opens when you tap on the list item, passing an event ID as an argument. Now, going through the code walkthrough, we have a lot of conversions in the app that we have to discuss. First, we'll go to the event.java file. This is the event entity that stores date time as a long epoch millisecond, where storing the date in as a number instead of string helps in making the sort work, or else the sort won't work. As you can see, the event is already sorted. Event list is already sorted. The DAO does event DAO. It has a function where we are basically order by date time ASC, which is basically ascending order, and the list comeback is already sorted. Now opening date utils.java. So in here, this is where conversion to human readable text happens. Simple date format with this pattern turns the long epoch milliseconds into Tuesday, 26 May or 28 May 2026 with the time. One central formatter means consistent dates everywhere. Now add event fragment. We'll go to combine date and time. So what happens here, this is where the conversion happens in the other direction. The date picker returns one long for the date, and the time picker returns hour and minute integers separately, and then we use calendar to combine them into a single epoch millisecond value before saving. Now we have the event adapter where basically category to color conversion happens. Each category, as you can see, we have the function bind where each category string maps to background and foreground. Hold on. Yeah, coming back. Event adapter, yeah. So color conversion happens over here where even category string maps to background and foreground colors for the chip. Now, going back to the persistence and validation, we have event database where we have um, Rome is wide in three classes. Event is the entity. Event DAO is the interface defining queries, and event database is the abstract Room database. Room generates the implementation at compile time via the annotation processor. Event repository. Going to event repository, we have all writes go through this repository on a single thread executor service. So the main thread is never blocked. Reads are live data, which Room handles threading for automatically. Everything happens automatically, no blocking happens. And this handles the concurrency. Now add event fragment. Here we have the function say where we handle all the validation. Validation is in three layers. Empty title shows a inline error on the input field, as you could see there. Missing date shows a snack bar. Pass date shows a snack bar. The date picker also disables pass date at the UI level using date validator point forward. Where is it? Date validator point forward. Date validator point forward dot now function, which is why the grayed out past dates were grayed out. And that covers all four mandatory subtasks: CRUD operations, room persistence, jetpack navigation with fragments and a bottom nav, and validation with user feedback through snack bars and inline errors. Thank you.